Hey everybody, in this video we're going to talk about the mean value theorem for integration and the average value of a function. So if f is continuous on the open interval a to b, okay, we would get something like this. So this could be our f at x. And it's continuous on a closed interval a to b. So this would be a and this would be b. So if that's true, then there's going to exist at least one number c in the interval a to b, so there's going to be a c somewhere in between here, such that the following thing is true. And that thing is the definite integral from a to b of f at x with respect to x equals f at c times b minus a. Okay, so that's the c value that we were talking about right there. Well, what is this? Well, if you look at the definite integral from a to b of f at x dx, this you can think of as the area under the curve. Okay, so that can be the area under the curve. And so if I were just to extend these sides up here a little bit, we'll be able to see that area just a little bit better. And so the area under the curve would be right here. Okay, we'll fill that in. Okay, so that is our definite integral. Now, if you look at f at c times b minus a, well, what is b minus a? Well, b minus a is this length right across here, right? So that's going to be b minus a. And f at c, then, is going to be some sort of height. And the height of that f at c is going to make those two areas equal. And so if I just draw this here, what I'm basically trying to do is make the area of this rectangle equal to the area under the curve. And so where would that be? Well, it's going to be where there's just as much area above it as there is missing area below it. So maybe somewhere like right there. And so what that allows me to do is figure out where this c value should be, and it looks like the c value would come right down here. And so my c value actually should be right there. Oops. Okay, so I get my c value right there. Now, this f at c that it traced to over here, that f at c is actually going to be the average value of the function. So the mean value theorem just guarantees that there has to be some c value that gives you the average value. And so when I look at this rectangle, this f at c right here, f at c times the b minus a gives me the area of this rectangle, and all that has to equal the area under the curve. Now, if you want to find the actual average value of the function, what you can do is actually take this formula and then solve for f at c. So in order to do that, I would have to divide by b minus a on both sides. Okay, notice it would cancel there, and you'd be left with f at c, the average value. And so that formula is actually right here where you divide by b minus a. All right, and so then the average value is just solving for that f at c, and that's going to be equal to the definite integral from a to b of f at x dx, and then times 1 over b minus a. Now, another way you can think about this is if you had something like a wave. Maybe there's a wave, and this was inside an aquarium. And the water can just be kind of like going all over the place. That can be represented by the curve, by f at x. So that's kind of your uneasy, uneven water. Now, if that water was allowed to settle, all the area would kind of settle down and it would end up being flat, and then you would actually get the average value of the function. It's the actual water level there. So just something to think about when we're looking at these problems. So the first thing we want to do here is try an example. And so it says, find the average value f at c guaranteed by the mean value theorem for integration. And so we have f at x is equal to x cubed minus 4x squared plus 3x plus 4 on the interval 1 to 4. Okay, so let's just take a look at what that means. Here is our interval 1 to 4. And again, I'm going to draw this up a little bit higher, more like the sides of an aquarium. Oh, we got to go quite a bit higher here. Get the whole thing in there. And then we're going to go all the way to 4. Okay? So, again, what we're trying to find is where this area, okay, equals the area of the same rectangle. So if I go ahead and draw this line again, we can estimate in our mind where we think that would be. And so here it looks like, gosh, somewhere maybe in here. And again, what we're trying to say here is that this area right there would equal this area right here. And if that's true, then that would make this my C value right there, and it would give me f at C right here. So let's go ahead and determine what this is and see how close we actually get to that answer there. All right. So we're going to say f at C, which is the average value, is going to be equal to 1 over b minus a, which is 4 minus 1, times the definite integral from 1 to 4 of the function, and that's x cubed minus 4x squared plus 3x plus 4 with respect to x. So as we solve this, we can get 1 over 3. And then we need to take the definite integral, which we can do using the fundamental theorem of calculus. So we're going to go ahead and use the square bracket and now find the antiderivative. So x cubed will become x to the 4th over 4. And then minus 4. X squared becomes x cubed over 3 plus 3. X will become x squared over 2. And then 4 will become 4x. Now, fundamental theorem says we're going to evaluate this from 1 to 4. All right, so now we're going to substitute in the 4, and then the 1, and then subtract the 2. So we're going to have 1/3. Okay, and then we're going to put 4 in first. So 4 to the 4th over 4 minus 4 times 4 cubed over 3 plus 3 times 4 squared over 2 plus 4 times 4. So that's substituting in the 4. And now we want to substitute in the 1. So minus, or plug in the 1, it'll be 1 to the 4th over 4 minus 4 times 1 cubed over 3 plus 3 times 1 squared over 2, and then plus 4 times 1. All right, so there it is. Now we just have to kind of calculate this out and figure everything. And so it actually turns out that this becomes, when we do it all, 57/4. So I'll save you the trouble of calculating that entire thing. And now we want 1/3 of that. So the area under the curve, that green part, is 57/4. And if I divide it by 3, which is the width of the tank right here, right, because that's that 4 minus 1, it technically should give us the height of the tank right there. And so this 1/3 times 57/4 is really 57/12, which is about 4.75. And that is our average value. Okay, so how well did we do? How well did we do? Well, if we look over here, look where our f of c is. We estimated pretty close to 4.75. Maybe we're a little bit high, but again, we were pretty close on that. So this should actually be a little bit lower at 4.75 right there. All right, so that's how to find the average value of a function. Take the definite integral and then divide by the width of the interval. Now, in the next example, it says, find the value of c guaranteed by the mean value theorem for integration for the function f at x equals the square root of x on the interval 4 to 9. So in this case, we don't want to find the average value. We actually want to find the value of c, the value of c. And so to do this, we actually have to find the average value and then solve for C. So it's a little bit annoying, one extra step from what we did before. All right, so let's just draw this out. We have, here is 4, and here is 9. Okay, and again, what we're looking for is this area under the curve. And if this were to be water and were to settle, where would this settle? Okay, somewhere in here. And what we want to do is figure out this f at c value, wherever that happens to be. And then it looks like we're going to go right here. We're going to try to figure out exactly where that c value is. Okay, so which c value gives us the average value is what we're essentially saying there. So it looks like we're a little bit over 6, estimating where that is. So let's go ahead and calculate this now. So what we want to do is go ahead and find let's see, f at c. And that's going to be 1 over b minus a, so 9 minus 4, times the definite integral from 4 to 9 of my function, the square root of x, with respect to x. All right, so we're going to simplify this. 1 over 9 minus 4 is 1/5. And then I am going to rewrite this as x to the 1/2 before we take its antiderivative. We're going to apply the fundamental theorem of calculus. Okay, so again, that's going to be raise the power 1 and divide by that new power. So it will go x to the 3/2. And instead of dividing by 3/2, I'm just going to multiply by 2/3 right away. And then we're going to evaluate this from 4 to 9. All right, so that basically means we're going to plug in 9 first and then 4 second. Okay, so we have 1/5 times, okay, we'll plug in 9 first, so 2 times 9 to the 3/2 over 3. And then we're going to plug in 4, and we're going to subtract the 2. So minus 2 times 4 to the 3/2 over 3. Okay, and we'll calculate this. I think it turns out to be 38/3. So we'll just come up here. F at c would be 1 over 5 times 38/3. Okay, and again, you just have to calculate all of this right there. And now we'll just distribute the 5, and so we really get 38 over 15. Now that's going to equal f at c, and that's about 2.53, just so we can see that our estimate kind of makes sense, and you know that looks pretty good at 2.53 right there. So that is 38 over 15. But what we want to do in this case is find that value of c. And so we're going to go back to f at x equals the square root of x and figure out where that equals 38 over 15. Okay? So again, we say f at c would equal 38 over 15, and we want to solve for c. So this turns into the square root of c equals 38 over 15. And to solve here, we would square both sides. And so c is going to equal 1,444 over 225. You can use a calculator for that. And this is approximately 6.417 repeating. So using a calculator, you would get that. Now, when you look here at that c value, it looks like we estimated pretty close. So this c value is actually 1444 over 225. And that is the answer that we're looking for. Okay, what c value is going to give us the average value? All right, one final question here. And this one, our f at x really isn't a function. It's just given by that curve there. And technically, these dots should be filled in, okay, because this does have to be continuous on a closed interval. So when we fill in the dots, we make that happen. Now we want to evaluate the definite integral from 1 to 7 of f at x dx. And so we're going to see that as being the area under this curve. Okay, area under the curve. And so, if you kind of look at some of this, I do have a big rectangle here. So that's going to equal 6, I think. So let me just do it this way. Maybe use a different color. Okay, so I do see this rectangle right here. And that's going to equal 6 in there. And then I see a couple other triangles. I see a triangle right here. Now that has a base of 1 and a height of 2. So the area is 1/2 base times height. You get an area of 1 there. And then I see another triangle right here. That has a base of 2 and a height of 1. So 1/2 base times height also equals 1. So it looks like overall I have a total area of 8 right there. 6 plus 1 plus 1. So if I want to find the average value of this function on the interval 1 to 7, well, I can really just divide by the width of that interval. And the width of this interval is going to be 7 minus 1, which equals 6, the width of the interval. And so if I want to find that average value, I can really just take 8, the total area, divided by 6, and that gives me my average value f at c. And so 4/3 is right there, and we can see that that's about 1.3. So right about there would give us that average value. All right, so that's the mean value theorem for integration and the average value of a function.